Bismillah, this will be a midterm exam simulation where we will be going to solve the midterm question in real time, and we will see how much time it will take and what should be the strategy of addressing questions like this. So in the screen, you should be able to see the exam paper, and also I'm going to be using Microsoft Paint for solving the question. I'm using the writing pad, my pen, as well as my calculator. So inshallah, according to the time here at the bottom here, it is 11:36 a.m. So let's consider the exam to be okay. Let's take a look at the question paper. Midterm exam. It is 2 hours. Right, the exam is 2 hours. So let's consider the exam for this time of recording from 11:30 a.m. until 1:30 p.m. Right? 11:30, 12:30, 1:30. Right? So it means that 7 minutes have passed. Maybe we use that 7 minutes to read the cover page, to know the time, to write our name, etc. There's 4 questions. Make sure you know the 4 question. Direct solution of simultaneous equation using programmable calculator is not allowed. Any form of cheating is lead to dismissal. Work can be done using pencil and or pen, but the final answer must be written in pen. Alright, so make sure you read all of the necessary information. So meaning that all simultaneous equation have to be shown on paper. Right, so 4 question, 2 hours. We'll allocate half an hour for each question, inshallah. So 8 minutes have already passed for the first question. Let's go straight to it. Now, question 1. So 4 forces act on a cuboid as seen in figure 1. So this is figure 1. This is a cuboid, and it says 4 forces. So we have F1 here 5 kilonewton, F2 here 3 kilonewton, F3 9 kilonewton, F4 14 kilonewton, and the dimension is given. Okay, given that the unit vector of F3 and F4 is given as such, U3 is this one, U4 is this one, meaning that for F3 here and F4 here, for the direction unit vector is given. The other two should be straightforward because this is along x-axis and z-axis, sorry. F1 and F2 is along x-axis, so the direction is known. Express the forces in Cartesian vector form. Okay, so this should be free marks because not free, you have to do and write, but it's straightforward. Just express F1, F2, F3, F4 as Cartesian vector form, and then determine the resultant force in Cartesian vector form, meaning that you just add all the 4. Also calculate the magnitude and coordinate direction angles of the resultant forces, and then is cuboid in equilibrium? Why or why not? Please explain. Alright, so let's do this. So first, express forces in Cartesian vector form. Alright, Bismillah. So this is question 1, right? And then part A is expressed in Cartesian vector form. So A. So we have to express each in Cartesian vector form, right? So for F1, so as you can see here, F1 is straightforward, forward up. So it's straightforward. F1 equal to 5 kilonewton. Okay, I cannot see the full thing. So let's, okay. So it's basically if you write in full, it will be 0I plus 0J plus 5K kilonewton. That's the first answer. F2. F2 is along x-axis 3 kilonewton. So 3I plus 0J plus 0K kilonewton. Now for F3, it gives you already the unit vector, right? So it just multiply, right? So F3 here, down here, 9 kilonewton, and then U3 is given. So F3 is simply F3 magnitude times U3 unit vector. So meaning that it is 9 9 kilonewton times minus 2 over 3I plus 1 over 3J plus 2 over 3K. So equal to, so 9 times, so 3, 6, is it? Minus 6I plus 3J plus 6K kilonewton. Double check. We copy the unit vector correctly. Minus 2 over 3, 1 over 3, 2 over 3, and then okay, of course we can check here, right? Meaning that this thing, if you get the magnitude, it should go back to 9, right? So we do square root of 6 square plus 3 square plus 6 square, it should be 9, right? Alright. Next, f4 is going down there, and the unit vector is what? This one, right? So f4 is 14. Okay, I cannot see fully here. 14 kilonewton. So f4 is simply f4 times unit vector of 4. So it's 14 times, what's the unit vector for E4? 3 over 7I plus 2 over 7J minus 6 over 7K should be 14 over 7 to 6I plus 4J minus 12K, right? Kilonewton. Just double check the magnitude. 6 square plus 4 square plus 12 square, 14. Alright. Now, if you notice, I have a habit of always check and double check, because not to say I'm always not sure of what I'm doing, but you know, in exam mode, normally it's safe. It's better safe than sorry, right? Alright, so just to check, for the first question, express the Cartesian vector, we have done that. Second, determine the resultant force in Cartesian vector form, also calculate magnitude and coordinate direction angle. So we have two parts of part B. Alright, so part B, one is FR vector, right? So this is straightforward, F1 plus F2 plus F3 plus F4, right? Simply summation of those, and we have already expressed it above here, so we'll just add all the components, right? So for X component, so 0 plus 3 plus minus 6, 0, 3, minus 6, and 6. So you get 3. So 3i. Y, 0 plus 0 plus 3 plus 4. It should be 7. So plus 7J, and then for K, 5 plus 0 plus 6 minus 12. So it becomes minus 1 K kilonewton. It's kilonewton, right? Yeah. So just double check. 0 plus 3 minus 6 plus 6 is 3. 0, 0, 3, 4 is 7. 5, 6 minus 12 minus 1. Alright. what is, and then okay, that's the first one, resultant force in Cartesian vector form. Then find the magnitude and coordinate direction angle. So magnitude is simply just square root, right? So FR is square root of 3 square plus 7 square plus 1 square, square root everything. Basically you will get square root of 3 square plus 7 square plus 1 square, square root of 59 was my, okay, square root of 59, or if you write in the value, in term of value, magnitude 7.68 kilonewton. So that's into decimal point, 7.68 kilonewton. What about coordinate direction angle? So alpha is cos minus 1 here, so it is, let's see the, so FR is here, okay, so basically x component divided by this one, right? So 3 over 7.68, you should get cos 3 divided by 7.68. Wait, what? Cos 3, okay, my calculator is not clear, 3 over 7.68, 67 degrees, 67.0 degrees. Okay, so for beta it should be 7 divided by, right? So beta cos minus 1, 7 by 7.68, it is 7 at positive 7, right? And then cos 7 divided by 7.68, 24 degrees, 24.3 degrees. Again, cos 7 divided by 7.68, 24.3, and gamma, it is minus 1. So cos minus 1 minus 1 over 7.68, cos minus 1 divided by 7.68, 97.5 degrees. Again, cos minus 1 divided by 7.68, 97.5. Alright, double check is that the question. So we have determined Cartesian vector form of the resultant force as well as magnitude and coordinate direction angle. Now part C is the cuboid in equilibrium. Why or why not? Please explain. Right. So is this thing in equilibrium? So this is part C. Now what we have, actually if you look here, right, what we have right now is resultant force is given as such, right? This is the resultant force, meaning what? Because and the resultant force is already additional of all the 4 forces, so meaning that it is not in equilibrium, right? Why? Because for because summation of force or FR is not 0. So that's basically the reason, because for equilibrium resultant force must be equal to 0, right? So in this case, when we add up the 4 forces, you get some value. So that's question 1. So we have answered A, B, and C. Just double check whether we have covered everything. Question 1, A, express forces in Cartesian vector form. We have expressed the 4. Second, part B, resultant force in vector, we also have done that. Magnitude and coordinate direction angle, so both magnitude and coordinate direction angle is calculated. Double check. Yep. And then is the equilibrium in equilibrium, why and why not, please explain. So we have explained basically, not in equilibrium because summation of forces not equal to 0. Alright, so it's 11:50. So we have used 21 minutes. Actually 21 minutes including the 8 minutes that we haven't done anything before, right? At the beginning of the recording. So actually this question number 1 does not require you to solve it in half an hour, but we would just want to see if we cover this for half an hour and then the rest of the question is also half an hour each, can we solve it all? So that's the test. So we'll just wait another 8 minutes before 12 to go to question number 2. Okay, so it's 12 p.m. So we'll do inshallah in the next 30 minutes question number 2. This is again a simulation where we will try to do each of the question in the midterm, in a real midterm, in real time, and to see how much of the time that we need to complete this question. Alright, question number 2. The pipe has a 116 Newton force acting on its own, acting on it as shown in figure 2. So this is the figure. So we have the pipe, we have point A, point B, point C here, and then force 160 Newton, and then we have the angle given there. So 2 parts. Determine the resultant moment about A, express the result as a Cartesian vector, and then determine the moment about line BC, express result as Cartesian vector. Right, so 2 questions, and hopefully you understand what the question wants. One is resultant moment. Now in this case there's only one force, so when we say resultant moment, it will be just due to that one force. So moment about point A, so this is a moment about a point, and the point is point A. Second is moment about line BC. So we have here B and C. So basically the question basically asks us to draw a line here, line BC, and what is the moment from the force or by the force to line BC, right? So that's moment about a line. So make sure you know the equation for both and what to do, right? So alright, so this is the diagram. Okay, let's put it here. So the first question is the moment about point A. Alright, so this is question 2, right? So question 2, part A is moment about point A. Let's just check moment about point A, about this point here. So moment about point in terms of the equation is M equal to R cross F, right? And this is the equation for moment about a point, and this R is from the point to the force, and F is basically the force, right? So meaning that for R it will be from point A to this point here, which is not having, okay, can you see this if I put my face here? So it is from point A to this point of the force, right? So A something here. If this is, because it is A, B, C, if this is point D, so it's AD basically, right? So basically here is R, want to express it first. So X axis here, Y axis here, Z axis upward. So X component from A to this point is 4 plus 3.5, which is 7.5. Oops, why is this 7.5? I, this 4, and okay, and then y is here positive 5, so plus 5j, and then it goes down 3, right? So minus 3k. Alright, what about the force? Force in vector form, so we have here so 160 cos 25 sine 35 degrees I, and then positive as well, 160 cos 25 cos 35 degrees G, and then going down, right, the Z component minus 160 sine 25 degrees. Okay, right. By the time of midterm, I assume you can do this, right? But it is not compulsory to do straight away. You can do the two triangles step by step as well. It will give you the same answer, right? But if you have done enough exercises, I think this already have, you have already the ability to do straight away. But you can do a step by step to the two triangle as well. It's just the same step. So 160 times cos 25 times sine 35, 83. Where's my 83.174 I. So double check, 160 times cos 25 times sine, sine 35, 83.174. okay, and then okay, plus 160 times cos 25 times cos 35, 118.785 G minus, so again double check, 160 times cos 25 times cos 35, 118.785. Alright, so now 160 times sine 35 minus 67.619 okay, double check, 160 times sine 25, 67.619. Alright, so that's the force. So we have already R, and then we have already F. So next is just to plug into the matrix, right? So M equal to I J K. What's the R? 7.55 minus the 7.55 minus 3. That is correct, right? And then the forces, 83.174, 118.785 minus 67.619. Alright, now we have to solve this matrix. So double check the forces is the same. Alright, so if you use the close down method, so you basically have I here, and then 5 times 67.619 of course it become negative, so it will be negative 338.095, and then 3 times 118.785. So minus become plus 356.355. Okay, double check. So 5 times 67.619, 338.0895, and then 3 times 118.785, 356.355. all right, and then minus G. So 7.5 times 67.619, but this is negative, right? So negative 507.143, and then negative become plus 3 times 8, 3.174, 249.522 plus K. Okay, so 7.5 times 118.785, 890.888. So, and then minus, so double check, 7.5 times 118.785, 890.888, and then 5 times 83.174, 415.87, 870, right? Double check, 5 times 83.174, 415.87. okay, so what's left for this part is just to add, so minus 338.095 plus 356.355, 18.26I, double check, minus 338.095 plus 356.355, 18.26. all right, so minus 507.143 plus 249.522, and then you have to minus back again, so it become plus 257.62 J, double check, to 57.62, and then 890.888 minus 415.87, 47 plus 475.02 K. The question asks for that one, right? This is the moment about point A, so it should be what's the unit above. For forces is Newton, and this is meter, so Newton meter, right? Part B. Alright, so that's answer. Where's my mouse? Part B. So what is it again? Moment about line BC, right? Oops. Moment about line BC. So B and C. So alright, so B and C. So if so moment about line BC. So moment about an axis, right? Moment about an axis is U dot R cross F. And this unit vector is unit vector of the line, the line BC, right? So unit vector BC. Okay, so for unit vector BC, we'll have to start from R, right? So RBC is RBC, right? So 6.5 I minus 4 J and 0K plus 0K, right? Because it's on the same plane. So here 6.5 and then this one, so meaning that this is minus 4. Alright, so RBC, the magnitude is square root of 6.5 square plus 4 square. Of course, if you want to put complete, it become like that, plus 0 square. And what do we get? Square plus 4 square. You get 7.632. 632 6321. Okay, 7.632. Okay, I'm so tired already. So UBC is RBC vector divided by RBC magnitude. So you get 6.5 divided by 7.632. 0.85 I. 6.5 divided by 7.632 852. Alright. Then 4 divided by 7.632 minus we have 0.5 24J plus 0K. We can actually check whether this is accurate unit vector, right? So if you get the magnitude 0.852 square plus 0.524 square, you get 1.0002. Okay, so it's close to 1. So that's unit vector for BC. That's for this, right? Then what is R here? R here, it is from B to the point of force, right? Either from B or from C to point of force. So let's use as the B one, right? So R, how to differentiate this? So R vector is 0I plus 7.5 J minus 3K. That's R. And F is as before. F is so if you copy this, right, if you write back to copy and then paste, right? So of course in the real exam you cannot do as such copy and paste, so let's give you 1 minute to write this one, right? So F is just repeating the same before, which is 83.174i plus 118.785j minus 67.619 k Newton. Right? Okay, we have to express everything in Cartesian vector. So above is already, this is the answer, right? Just now, yeah. Okay, so we have done that. We have the three components that we need. From U is the unit vector of the axis itself, R is from the axis to the force, and F is the force. So UBC is the line that the question actually want. R is from B to this force, so we have 7.5. Sorry, this is wrong. Okay, this is wrong, right? I is here. Okay, thank goodness that I check. So this is wrong. Okay, so it should be 7.5. Oh, 7.5 I plus 0g, right? Okay, so yeah, 7.5 in the x-axis, 0 in y-axis, and minus 3 in z-axis. Okay, is there anything else that I have to? So it should be mirroring this one, right? Just that this 5 is no longer there, so 705 0 minus 3. All right, what else? Hopefully I do not make any other mistake in this simulation video. Okay, so then moment in terms of the matrix, so unit vector is there, so let's put that one first. So you have 0.852 minus 0.524, and then we have 0. And that's the unit vector, right? And then the R, 7.5, 0 minus 3, and then force 83.174, 118.785 minus 67.619. So this is the matrix. Oops, double check, is that accurate, everything? Okay, so you have 0.852, and then okay, 0 minus become plus 3 times 118.785, 356.355 minus 0.524, then 7.5 times 67.619. That would be, this is negative, so that would be negative 507.143. 7.5. Okay, just to check above, is it consistent with the above? 507.143. Okay, and then 3 times 83.174, 249. Okay, this becomes plus 249.5 point 259.522. Okay, and then plus 0 this doesn't matter, right? Because this is 0. Alright, so if you do this, 356.355 times 0.852, that one you get 303.614. And then what about this one? So this is, okay, we sort out inside here first, minus 507.143 plus 249.522, then times 0.524. So it is minus 134.993. So 303.614 minus 134.993, and then you get 168.62 Newton meter. This is in Newton and meter, right? So that is the answer. Now it mentioned that both answer is in Cartesian vector form. So this is in Cartesian vector form, as this is, okay, this is not Cartesian vector form yet. Okay, sorry. So we have to get in Cartesian vector form, right? So this is, you have to multiply by this 168 multiplied by where's the unit vector? Unit vector BC. So because of the unit vectors, I don't remember. So I'll copy this one and here. Oops. So M is above, so hence, okay, we have 4 minutes left, hence M equal to 168.62 times 0.852, 143.7i, and then 168.62 times 0.524 minus 83.4 J plus 0 K. This would be the answer, and then this is unit of Newton meter. Alright, so we did this from 12 to 12:30. So we have another 3 minutes time left if you want to check anything. Yeah, so that's the answer there. Again, just double check. We have the question asking for moment about point A at a moment about line BC. So that's the answer. Right, so we have 2 minutes before 12:30. Yep. So it is possible, even though I make a mistake and I realize it after that to make the correction. I think, where did I make the mistake? This R, right? No, this R. So make sure you double check, because sometimes we make meaning just like I did make the how to say, bit confused between X and Y. So that's why I think I have developed a habit of always check, double check, triple check, because we still have time. We still have one more time to complete the 30 minutes, and you can see how slow I do this question, because I keep checking, and as well I'm so sleepy right now. That's why I'm so slow at doing this one. But the time given, it should be enough even if you do as slow as this one. So we'll prepare for question number 3. Okay, this is question 3. Consider the beam AB to have negligible thickness. So okay, this is the beam. You have beam A to B supported as shown, and then this beam also have something like this, right, attached. So consider the thickness is negligible. Okay. Based on the loadings acting on the beam AB as shown. So this is based on the loading. So what loading do you have? We have here distributed loading. We have here 600 Newton. This have here 500 Newton. We have here 450 Newton per meter, sorry. And then we have here 200 Newton. So those are the loadings that we have. Distributed loading here, point load here, point load here, distributed loading here, and point load here. So based on those loadings, first determine the equivalent force and couple moment at point A. Draw the beam AB with the equivalent force and couple moment at point A. So make sure you understand the question first. The question asks for what? Determine the equivalent force and couple moment at point A. Right. So meaning that if we find the equivalent, meaning that we have a single force and single couple moment at point A, what is it to equivalent of this one? And then you have to draw. And second, determine the equivalent force. So now the equivalent force acting at point AB along the horizontal line A and B along this line, and specify the distance of the force from point A. So meaning that this is further simplification. So in statics, part A is simplification to have one force and one moment. Part B is further simplification to just have one force and find the distance, right? So do not be, this is not really a trick, but do not how to say, because some students just looking at the diagrams, for example, they see this diagram here, straight away they solve for support reaction for whatever reason, because the question do not even ask for support reaction, right? So do not go and spend the time on something that you shouldn't do. What you need to do here is determine the equivalent force and couple moment. So find equivalent force and couple moment and the equivalent force, the further simplification. Do not calculate something else that is not asked by the question. Even though the diagram seems to be similar to another topic, another chapter, that doesn't matter because the question is the question. Alright, so let's put this aside. So how to do this, how to make it visible. Alright, so let's, okay, so let's give the space. Alright, so this is question 3. Question 3. So again, time here, so we consider question 3 is from 12:30 to 1 p.m. We have, as mentioned earlier, in the block of half an hour. Alright. Okay, equivalent force and couple moment. So first, to find equivalent force, what we do, because this is 2D, sorry, we just find every single, meaning we have find summation of force in x-axis, summation of force in y-axis, and then we can find what is the resultant of the two, right? So summation of force in x-axis, taking positive to the right. So what do we have? This distributor already do not have any x component. This one 600, so 600 there, 500 downwards, no, 450 here, no, and then this 200, so minus 200, nothing else, so it should be equal to 400 Newton. Find summation moment, summation of force in y. If I take upwards as positive, so this 400 Newton. Okay. Okay, to be able to solve this one, we actually have to solve, or how to say, to resolve this, to transfer or transform this into single point load first, right? Alright, so I haven't done that, so let's do this here. So meaning that for, okay, we have several things. Here is the triangle, so consider this triangle here. So the force will be here, right, with 1/3 and 2/3. The distance, the total distance is 3 meter. So meaning that this is 1 meter, this is 2 meter, right? And then the force, the value is the area, so half times 400 Newton per meter times 3 becomes 610. So that's that one. And then we have the rectangular there. So force, equivalent force should be at the middle there. So the whole length is 3 meter, is it? 3 meter, so meaning that 1.5 meter, 1.5 meter, right? And then the value here will be just 400 times 3, which is 1200 Newton, right? What the unit inside, I'm not writing here, but the unit inside is Newton per meter times meter becomes Newton, right? I'm not sure how some students still have issues with the unit here. Alright, that's that. And then what's the other one is this one below, right? So let's do this here. So something like this. So it will be there. Of course, it's half 1/3 and 2/3 distance, right? So the total distance is 9. So meaning that this one 1/3 become 3 meter, right? And the rest is 6 meter. What about the value? It will be half 450 times 9 equal to 2025. Alright, so having done this, going back, of course, should it be going back? Okay, if we want to make the flow logical. Now, summation of f(5) I take upwards as positive, so this one downward 600, so minus 600, minus 600, and then this rectangular beside it is 1200, so minus 1200, and then 600, no, why? So this one is minus 500 at the end there, and then plus 2025. If you calculate this, minus 600 minus 1200 minus 500 plus 2025, you get minus 275 Newton. This means it is downward, right? So what does this mean? We have 400 to the right, and so meaning that we have 400 Newton to the right and 275 Newton downwards, meaning this will be FR, and we have a theta there, right? So FR is simply square root of 400 square plus 275 square equal to square root 400 square plus 275 square, 485.41. Then double check, square 400 square plus 275 square, 485.41. Alright, and what about the theta? Theta equal to tangent minus 1 275 over 400. Then at tangent 275 divided by 400. 34.5 degrees. Okay, that's equivalent force and the direction, right? What about moment? So summation of moment about point A. Why point A is about, because the question asks for about point A, right? So let's take clockwise as positive. Okay, so okay, this one we would require some diagram, right, based on this. So if we have, okay, let us put this down. Okay, if you reconsider the whole thing, right? It will have this force, right? Of course, this force, and that force. All right. Of course, you have support, etc. Right. Now, this is 200 Newton. This one is, what was it again? 600 and 1200. 600 Newton, 1200 Newton. This is 600 Newton. This is, what was it? 202. Mana dah? Where is it? Oh, here, right? 2025. And this is 500 Newton. Now, the distance, right? So, okay, this is 4. No problem, this is 4 as well. This is 3. And then this is it 6? Mana pula my mouse? 6 meter, right? So that is 6 meter. This one is 1, right? For the 600. Sorry, 2. And that one is another 1 plus 1.5 equal to 2.5. Mana pula mouse ni? 2.5. And this one is, we have 3 plus 1.5, right? 3 plus 1.5, 4.5. Okay, so now we are calculating the moment. If we take clockwise as positive, so for this 600 is 600 times 2, and then plus 1200 times 4.5, right? And then plus 600 times 4, and then plus 500 times, how many is this? 2, 3, 4, 5, 6, 7, 8, 9. Is it 15? 2 plus 2.5. Sorry, there's another distance here, right? Because we calculate from A. Okay, sorry. Now I make a mistake because I consider from here. Should be from here. Okay, let's do what mistake. Right, it is point A here, right? So the distance from there. So again, okay. So I have to I have to check everything, so I'll do this. All right, so 600 times 4, 604, and then 1200 is 6.5, and then the 600 is 4. Okay, this 100 is not affected, it should be. And then this 500 is like 2, 4, 6, 10, 11, 11, 17, 20, 20, and then minus 2025. The distance is 2, 4, 6, 10, 11, 11. And then we have this 200 here, which is plus 200, 4. So if you calculate that, 600 times 4 plus 1200 times 6.5 plus 600 times 4 plus 500 times 20 minus 2025 times 11 plus 200 times 4, 1125 Newton meter. 1125 Newton meter. This is clockwise, right? Okay, again the question asks for equivalent force and couple moment at point A. So equivalent force is there, angle is there, as well as moment is there. Draw the beam AB with the equivalent force and couple moment at point A. Alright, so meaning of course we have all of this, right? But the equivalent force, okay, what is the direction and the force? So it is like this, right? 485 in this direction, 485.4. So 485.4 Newton with the angle of 34.5 degrees, and then the moment is 1125 Newton per meter. Okay, so that's basically force and couple moment at point A. And then part B, so we have only, okay, this is part A, right? Part B, subhanallah. Part B, further simplification. What does it mean? It means that if you redraw the beam, just only the beam, boleh lah. Okay, let's, if you draw the beam, or should I just use this one? Okay, if ignoring the other shape, so it would be something like this, right? 485.4 Newton, and then angle of 4.5 degrees, and then we need to find what is the distance. So the distance is meaning that summation of force equal to 0 using that one. So 485 sine 34.5 degrees equal to this is the force, the vertical force, times the distance should equal to 1125. So meaning that D is 1125 divided by 485 sine 34.5. So D equal to 4.095 meter. Alright. Sorry. What am I doing? Why is this not having this 4, right? Okay, so if I... This magic can only be done using computer, but yeah. So let me check if that's correct. 1125 divided by 485.4 divided by wait, what am I doing? 1125 divided by 485.4 divided by sine 34.5, 4.091. So let's consider 4.09 meter, right? Oh, so the drawing is here. Above the drawing is there, all the values are calculated. So here the distance is the additional one because the rest is the same. Right, so that's the answer for part A as well as part B. We have another 7 minutes before 5, before 1. Another 7 minutes, yeah. So we'll wait for that before, at 1 we will continue with question number 4. Alright, so it is past 1 AM, so our time block for question number 4 is the last half an hour, which is 1 to 1:30. Alright, so this is the question. Based on the loadings acting on the beam AB shown in the figure, so we have shown here. First, determine the resultant moment about point A from the 4 external forces and a couple moments shown in the figure, right? So we have forces here. This is 400 Newton, this is 200 Newton, this is 500, this is 100, and then this is couple moment of 300 Newton meter. What is the resultant moment? Right, so just find the moment about point, this is about point A. So interestingly, in this final exam and this midterm exam, there's a lot of moment calculation involved. Yep. And then determine the support reaction at pin A and roller B. Note, any calculation which is not based on any free body diagram will not be considered. Right, that should go without saying actually, meaning that if you do not draw a free body diagram, how can you establish any equation of equilibrium? You cannot, because of the direction, etc. Right? Alright, so first, okay, this is question 4. So let's see, question 4. We have part A, which is resultant moment about point A. So moment, summation moment about point A basically, right? What is it? So let's take clockwise as positive. So let's do this. So about point A. Okay, so we go step by step. This one. 400. So okay, clockwise. So the horizontal one will be clockwise. So 400 3/5. That one, the distance is 1.5. 1.5 positive, right? And then vertical will be counterclockwise, so minus 400 4/5 0.8, right? The vertical one, 0.8. Next, the 200 Newton force here, the horizontal one, which is counterclockwise, so minus 200 cos 30 times 3. And then vertical one, minus 200 sine 30 degrees, vertical one times 4. And then the 500 one, the horizontal one, becomes positive 500, 3 over 5, 1.5, and then vertical downwards, plus 500, 4 over 5, 6, right? 4, 5, 6, right? And then horizontal 100 becomes negative 100, 3 over 5, 1.5, and then vertical down, positive 100, 4 over 6, 4 over 5. What am I doing? 4 over 5, 6. And then we have this 300 Newton meter there, so plus 300 Newton meter there. Alright, so this will, okay, to avoid mistake, let's do one by one, bit by bit. Where is it? Okay, 400 times 3 divided by 5 times 1.5, oops, 400 times 3 over 5 times 1.5 becomes 360, so 360, and then minus 400 times 4 over 5 times 0.8, 256, 256 minus 200 times cos 30 times 3, 519.6, 519, apa benda ni? 516.6. Wow, I fall asleep, I think. Again, 200 times cos times 3. Okay, then minus 200 times sine 30 times 4, 400. Oh, subhanallah. Okay, plus 500 times 3 over 5 times 1.5 plus 450, then plus 500 times 4 over 5 times 6, 2400 plus 2400 minus 100 times 3 over 5, 90. Again 100 times 3 over 5 times 1.5, 90. 100 times 4 over 5 times 6 plus 480, and then plus 300. Okay, wait, I make a mistake. Oh, I'm so sleepy. I make a mistake. Okay, this 100, this doesn't make sense. This is not 3.5, right? This is 30 degrees. Oh my goodness. Okay, so this portion is wrong. This portion is wrong. Subhanallah. Meaning what? Meaning this is wrong. Allahumma salli ala Muhammad. So this is meaning, okay, the battery is dying. So this is a reminder not to have lack of sleep during exam, because it messes with your brain. Your brain becomes so slow and it cannot detect obvious mistake. Okay, subhanallah. Now, so this is minus 100 sine 30. This plus 100. Sorry, not sine. See, cos 30 degrees, sine 30 degrees. So minus 100 times cos 30 degrees times 1.5 is minus 129.9, and 100 times sine 30 times 6 plus 300. Ya Allah. Okay, let's try this. 360 minus 256 minus 519.6 minus 400 plus 450 plus 2400 minus 129.9 plus 300 plus 300. 25. Where's my mouse? 2504.5. What is this? Newton meter, right? So yeah, this is moment about point A. Subhanallah. Okay, point B. This is the serpent support reaction. Meaning what? Meaning we have to draw free body diagram. So B, free body diagram. So we have here force 400 Newton. So we have normal reaction here. We have AX and AY there. So the distance, oops, let's use different color. This is 0.8 meter, 3.2 meter, 2 meter, 1 meter, 1.5 meter, 1.5 meter, 3 meter. Okay, alright. So based on this free body diagram, if we want to solve and B, we can take moment about A, right? So summation of moment about A equal to 0. Take clock is positive. So we will have all of the above, right, plus NB here, right? So if we redo it again, so basically we'll have 400 3 over 5 1.5 minus 400 4 over 5 0.8 and minus 200 cos 30 degrees 3 okay, going down minus 200 sine 30 degrees. What's the distance? 4. And then plus 500 3 over 5 1.5 plus 500 4 over 5 6. Oh. Minus 100 cos 30 degrees 1.5 plus 100 sine 30 degrees 6 plus 300 and then plus minus NB minus NB times 7 equal to 0. Subhanallah. So okay, it should be the same, right? 400 3 1.5 minus 400 4 5 800 minus 200 cos 3 minus sine 4 500 3 over 5 1.3 500 4.56 minus 100 cos 130 1.5 plus the sine less than okay. So meaning that the whole thing is should be, meaning if you add together it should be 25 should be this one. Copy, should be that one, right? So the whole thing is this one, and if you calculate back again, and then minus NB equal to 0. Sorry, no, minus NB times 7 equal to 0. So 2504.5 divided by 7, you get NB equal to 357.8 Newton. So NB is solved, right? And okay, what else? So after solving this one, we can solve the rest, right? So if you do summation of fx equal to 0, taking positive to the right, so we'll have minus 400 3 over 5 plus 200 cos 30 degrees plus 500 3 over 5 minus 100 cos 30 degrees. Wait, I have to refer to the free body diagram, right? Meaning that I forgot you have AX here, right? No, free body diagram here is missing something, missing this 300 Newton meter. Okay, the free body diagram again. AX ada NB ada this force. Okay, this moment is missing just now. Alright, so Okay, this one is okay, this one not affected, this one okay. Then plus ax, right? Equal to 0. Ax is here. So is this ax equal to minus 400 times 3 over 5 plus 200 times cos 30 plus 500 times 3 over 5 minus 100 times cos 30 146. So you get minus 146.6 Newton. So minus means it's to the left direction actually, because we assume to the right in our free body diagram here, right? Okay, so summation of Fy equal to 0 upwards positive. Okay, 400 4 over 5 plus 200 sine 30 degrees minus 500 4 over 5 minus 100 sine 30 and Ey, is it, plus Ay equal to 0. So Ay equal to, oh sorry, we have, wow, it's so bad doing. Okay, two things, because I'm referring here, I should refer to this free body diagram, right? Then okay, I noticed that Ay is here, NB is here, so NB is this one, right? So I should also add this one. Right. Ya Allah. Okay, subhanallah, 400 times 4 over 5 plus 200 times sine 30 degrees minus 500 times 4 over 5 minus 100 times sine 30 degrees plus 357.8. Subhanallah. So it becomes minus 327.8 Newton, meaning it is downwards. So that is the end, right? What do we have here? Because it asks for, what is it, support action at A and B. So we have free body diagram, so you have to find Ax, Ay, and B. So NB we have, Ax we have, Ay we have, right? So we have completed all the questions. All right, subhanallah. So yeah, I think I did quite significant number of mistakes. Now, what is the time? 1:25, right? So we have 5 more minutes within the 30 minutes time that we allocate for this question. My advice to you, I'm not sure how many are still watching by this point, because I don't know. So that's quite an interesting simulation where I did quite a number of mistakes that take some time to actually revisit and recalculate, but still the time allocation is enough. And second, I'm doing this whilst being super sleepy, because I'm severely like sleep right now. So the mind suddenly it goes off. It just, meaning my eyes are sometimes open, but my mind is not there. So that really affect the performance. So my advice, meaning have enough of sleep in your before your exam, meaning that you have to prepare way before, right? Do not study last minute so that you stay awake before the exam, and you might make, you know, bad mistakes, even though you understand, but because the mind is not you know, at full function or something, you might do some mistakes, severe mistakes, just like that. Anyway, so that's the simulation for this one. Hopefully it's still beneficial despite what happened. Yeah, hope you there's a lesson to be learned, right? Meaning that do check, double check, triple check to avoid mistakes. There's enough time, as we have seen here. There's enough time to do that triple checking. Have enough of rest and sleep so that your mind is fresh while doing this. Alright, so that's it for this video, for this simulation of this midterm. Hopefully this is beneficial to some, and yep, wallahu alam. Assalamualaikum warahmatullahi wabarakatuh.